Hey guys, so in this video I'm basically going to be talking about the lab report. Um, it's going to be for investigation 4. It's 2 pages long, double space, 3 sections, the background information, justification of process, and the argument section. Um, it's double spaced again, and it's going to be for the draft. So you guys will receive some type of feedback on it, and if you guys have more questions about it, you can email me and I can help you out with it. Uh, so, like we did in the pre-lab, we were trying to find the relationship between absorbance and molarity, right? So all that stuff, we want to include that in the background information, but you don't want to say we did this in the pre-lab or whatever. All you want to do is kind of like say that you found this and that, okay? But so starting with this, you're gonna include your guiding question, and that is what is the composition of a 1 liter solution of purple. And when we talked about that, we started talking about molarity, solution, and spectroscopy, right? So we said molarity is a type of concentration, and we also said that a solution is basically a solute that's dissolved in a solvent. And for spectroscopy, all we said is that we're using a colorimeter, and that's an instrument. So spectroscopy basically is how molecules absorb light, and it gets detected, and then it gets sent to a sensor or whatever, and then a graph comes out of it or some type of information. So you don't have to give me like in-depth information about it, but kind of tell me like what that is, and then you're gonna tell me how the colorimeter works. And you don't have to tell me like a whole explanation of it. Just one sentence is fine. You can just say something like, a light gets sent through the instrument, and it passes through a cuvette, and the molecules in that solution absorb light, and the rest of the light gets sent to the detector, and it basically subtracts the amount of light that was sent versus the amount of light that was detected, and tells you how much light was absorbed by the molecules, and it can tell you an absorbance value. Then another thing is why we're using red and blue, because in the pre-lab we determined the relationship between absorbance and molarity of red and blue. So why are we using red and blue? Well, it's because purple is made out of red and blue. So just say that, and just say that you did a serial dilution for red and a serial dilution for blue, and then you found the relationship between them, and those are the calibration curves. And then the relationship between absorbance and molarity was determined to be linear, right? So that's part of your background information as well as your justification. I want you guys to also include your equations that you got, and describe the use of absorbance to find molarity. So basically, after you got your calibration curves and stuff, then you took your purple solution and then put it in the colorimeter and set the wavelength to the blue wavelength, got that absorbance value, and used the equation of blue to find the molarity of blue in that purple solution, and that's how you found that. And the same thing for red. So that's it for the background information, and then for the justification of the process, basically like why you did what you did. And so you tell me, how did you find the relationship between absorbance and molarity? Well, that was, again, you did serial dilution. You can include the serial dilution tables that are in the pre-lab, include that in there so we can see how you made your graph. And then you also have to say that you use water to blank the cuvette, because that was your solvent was water. So you put water in it and then press call to tell the instrument that is 0, that does not absorb any light. So that's there, and then you have to tell me what wavelength you set up your instrument to. So 635 nanometers for blue and 470 nanometers for red. Also include the equations and the table. I already mentioned the table, but you also have to include the equations for red and blue. And when you do all this, like including the table and the equation, remember, when we put the tables, you have to put a title on it and make sure it's properly format. And with the equations as well, make sure you don't write them within the text, meaning that when you're writing your stuff, your sentence or whatever, then press enter, then in the middle you write that equation, and then next to it you write equation 1, and then press enter again in the middle. You write the second equation, and then write equation 2, and then press enter again, meaning that those equations will be outside of the bulk paragraph. So make sure you guys follow that format. I want you guys to show me one full sample calculation, meaning that so how do you go from the absorbance of your purple solution to the concentration of red or blue in that purple solution? And sources of error and how to reduce them. So we talked about this. Remember, so after each measurement, you're supposed to take a solution that you're about to measure, take like a couple of drops of it, and then put it in the cuvette, and then shake it up a little bit, and then dispose it, and then put the solution that you're gonna measure in it. That way, you're not over diluting your solution, and you have a pretty reliable absorbance for it. Then I'm gonna move my board because this board's not big enough. So I'm gonna move this to talk about the last part. It's crooked, so hopefully it doesn't fall, but alright, I think it's good now. Alright, so for the third part, the argumentation, you want to include your claim. An example of a claim would be this one. It says an amount of blank grams per liter of blank molarity of blue and the same thing of red was required to make 1 liter solution, 1 liter purple solution, whatever number, if it was purple solution 1, 2, or 3. So by this right here, you're telling me how much of blue you use of 1 molarity, you know, because having 1 molar of something is not the same as having 10 molars or something, because 10 molar is way stronger than 1 molar. And then you're also gonna tell me again why we're using red and blue, because that's part of your justification. Basically, you're using red and blue because purple's made out of red and blue. How precise were your calibration curves? And here's where you tell me that the relationship between absorbance and molarity was determined to be linear, and you know that because the R-squared value, and R-squared value basically means how well your data fits a linear plot. So if your R-squared value is close, really close to 1, that means that your data can be said to be precise. So when I have an R-squared value of 999, basically means your line is pretty much straight. But if I have an R-squared value of like 399, it probably look a little curved, you know, or it might look like, so these are your data points, and it'll try to make a linear plot against it, but they're also scattered, so it doesn't really resemble a linear plot. But if your R-squared value again is really close to 1.99 something, 0.98 something, you can say that your data is precise based on the calibration curves. Another thing is, why is this important? Well, this is important because that way you can determine the amount of red and blue in any solution if you have the calibration curves for it. And last thing will be compared to other groups. So in this case, we didn't do the whiteboard argumentation, you know, because of online classes, but we did PowerPoints and people presented the results. Compare those results to yours, and yeah, that will be it for the lab report. Email me with any questions, and I'm gonna put all of this in a PDF and then send it to you guys. All right, stay safe.